Hi, I'm Jim Heffron. These are my lessons in Calculus 1, and this one is we're talking about the problems for Chapter 3, Section 1, so we're really kind of getting into the meat of the course. So this should be fun. Let's get started. Okay, so the very first question is, as always, we like to go back to a prior section and keep it all fresh in our minds. So let's see, Section 2.6 and question 17. Let's see if I can dig it out here. Let's see, question 17, there it is. It says the limit as x goes to minus infinity, limit as x goes to minus infinity, t goes to minus infinity, 3t squared plus t cubed minus 4t plus 1. And as usual, I like to credit the text. Of course, that's the calculus book by Stewart, and it's edition 9. So let's see, the t goes to minus infinity of 3t squared plus t, and on the bottom of the fraction is t cubed minus 4t plus 1. Okay, and we've talked about before, the book has a little bit more technical approach, but for our purposes, as long as the limit of the denominator is not 0, we feel free to just say this is a polynomial, so the most important term is the one with highest power, and this is likewise a polynomial, so the most important term is the one with the highest power. So we're going to write that as the limit as t goes to minus infinity of 3t squared, because that has the highest power, and t cubed, because that has the highest power. Cancel the t's, limit as t goes to minus infinity of 3 over t. So that looks like a 1 over t graph. F of t equals 1 over t. So we know what happens when f of t equals 1 over t. We know what that graph looks like. We have some kind of picture like so. When t is a negative number, 1 over t is also a negative. So 3 over t is going to look something like so. Right, of course it goes to infinity at 0, and there's another side. But all that's not important. Our interest is in this part right here. Okay, so the answer is simply 0. Now it approaches from below, so you could say, it approaches from the negative side, but it doesn't actually matter. As t gets larger and larger and larger in the negative direction, you're looking at 3 over a very large number, even though it's a negative, but 3 over a very large number gives you a number close to 0. Okay, great. So now we're going to move to section 3.1, and I think these are going to go a little faster than some other days, so that's fun. So let's see, we're starting off with section 3.1, number 5 and number 7 and 13, and so here we go looking for number 5. And you can see 5 and 7 and 13, and they're just short ones, so I'm only going to copy it to my page. So x to the 75 minus x plus 3, and it says take the derivative. So I've got to take the derivative. Got to take the derivative with respect to x of x to the 75 minus x plus 3. And I use the other notation. I use the ddx notation just to mix it up, that's all. It is an advantage that you don't have to come up with a name for the function. You can just say take the derivative of this thing. Okay, the way we take the derivative is we're going to break along the minus and plus sign, and then I'll take the derivative of the separate parts separately. So in short, I get 75x to the 74 minus the derivative of x. Of course, x is it's technically x to the 1 power, so I get 1 times x to the 0 power, and anything to the 0 power is 1. So the whole thing is 1. And then the next comes a plus. You break along the plus sign. Derivative of 3 is 0. I'm not going to write plus 0, so I'm just going to leave it the way it is. All right, that's number 5. Number 7 is f of t is minus 2e to the t. So again, I'm just going to write it in the more compact form. Derivative with respect to t, I have to change the variable. derivative with respect to t of minus 2 e to the t. And I'm just simply quoting the formula here. I kind of hand waved around the explanation for why the formula is the way it is, but I'm just simply going to take the derivative of e to the t. So we had a formula that says when you want to take the derivative of something, you can bring the constant out. I'm going to bother to write that. That just says you can bring out a constant, and I brought out the minus 2. Anyway, the derivative of e to the t is e to the t. It takes a little getting used to, but it's right, e to the t. The point of e to the t is that the derivative is the value of the function. And then I'm looking for 13 was on the same page. So here it says s of t is 1 over t plus 1 over t squared. Now, we haven't seen how to take the derivative of a fraction, but we can, of course, write these as powers, so that is to say I could take the derivative as t to the minus 1 plus t to the minus 2. And now that's easy. I'm just following the formula here. So minus 1 t to the, don't write 0, write minus 2, and then take away 2 t to the minus 3 power. Okay, if the minus powers are something that you can use practice at, so this is minus 1 over t squared, take away 2 over t cubed. Okay, so let's see, that's almost all the problems, and then the last problem is number 19 on the facing page here. On the flip page, the over page. Number 19, you can see it says, whoops, you can't quite see it. There, that's a little better. It says x cubed times x plus 3. And again, the caution I gave in the slides, I'll give it again here, is that you can't take that as the derivative of x cubed times the derivative of x plus 3. In the first place, that's wrong. And in the second place, we haven't covered it yet. What we have to do here, because we have not yet covered the derivative of a product, because you have to multiply the darn thing out. Okay, so I've got to take the derivative of x cubed times x plus 3. So I don't know how to take the derivative of a product, and I've already cautioned you a couple times that it's not simply the product of the derivatives. So I'm instead going to multiply through. And that I know how to take the derivative of. So it is 4x cubed, and then 3 times 3 is 9, 9x squared. Okay? All right, great. So a short one. Always nice to have a treat.